Well, good afternoon, and thank you for that lovely introduction, Sharon. If you are going to take a nap, which I quite understand, it's after lunch, please keep the snoring to a minimum if you can. In the meantime, I'm going to see if I can just wake you up a little bit, just in case.
Buy it, use it, break it, fix it.
Buy it, use it, break it, fix it. Welcome to working on the web. This is exactly what it's like. It's been like it for the 20-odd years I've been playing on the web and working on the web. We use it as consumers, and quite often things feel like they're broken. We work on it, we build things. Quite often we break things. Good news is that there are a lot of things we can do to make both things better. And one of those things is accessibility. It's part of a toolkit that is web design. It includes good usability, security, performance, privacy, good code quality, good design, good interaction, and a whole number of other bits and pieces. But because this is Accessible by Design conference, of course, I'm going to focus on accessibility. And if you'll bear with me, I'm going to take a bit of a dive into some of the code aspects and development aspects of accessibility. If those things aren't really your bailiwick, don't worry. Hopefully there's some more good tunes to keep you amused along the way.
Trash it, change it, melt, upgrade it.
One of the great secrets to accessibility at the code level is that there is a lot of it out there for free, and we can basically upgrade on that accessibility. Most HTML elements that we use have semantic information available. It comes as part of the element for free. And by that, I mean that an HTML element has a role that describes its purpose. And quite often, that role is pretty obvious from the type of element we're talking about. So if we take the anchor element for creating links, its role is link, quite unsurprisingly. And an assistive technology like a screen reader that will translate content in HTML into synthetic speech, when it encounters a link, will say something like this.
Tink.uk, link.
It reads the text that comes inside the anchor element, that's its accessible name, and it identifies the purpose of the element based on its role and announces it to a screen reader user as a link. And we get that information for free with all sorts of elements. With an image element, for example, we give it a source file so the image gets displayed on screen, and we use the alt attribute to give the image an accessible name. In this case, the image is a picture of one of my favorite tequilas, Chumuca's tequila, and it has a very distinctive logo, which we've described in the alternative text. The image element has a role of graphic or image, depending on which type of computer and browser you're using. And so a screen reader will wrap up all that information and say something like this.
Graphic, a bottle of Chumuca's tequila with the dancing devil logo.
If we look at something like a checkbox, an input element with a type of checkbox, we can, again, get some useful information. It has a role of a checkbox, and it has some other characteristics too. We know that it can be focusable. We know that it can be checked because it's a checkbox, and at the moment, we can tell whether it's in a checked or unchecked state. We can also get a name for the checkbox based on its associated label element. And again, a screen reader will pick up all that information that's just there in the HTML and make it available to the user.
Tequila, checkbox, checked.
Sharon really wasn't joking when she said I like tequila, so you know, her research was good. There are a couple of elements that are an exception to this rule, though. The div and span elements don't really have strong semantic information available. Technically speaking, they do have roles like other elements, but browsers and assistive technologies like screen readers don't do anything with them. So any content that appears inside a div or a span element is treated pretty much like plain text. So if we take an example where we have some content inside a div and span element, maybe something that when we've styled it and given it JavaScript functionality will actually be a button, or pretend to be a button. What we find from the screen reader user's point of view is that all it's aware of is the text inside the div and span elements. And so other than that text, there's no other information that the screen reader can make available to the user.
Add English breakfast tea to basket.
Now, a user might be able to guess from just hearing that text that actually maybe if we hit the enter key or clicked our mouse on that piece of text, it might do something useful. But nothing said this was a button, nothing said it was a link, nothing said it was a form field or anything that gave us a clue that we could interact with it. So that's a big part of web development today, is figuring out what we need to do when we have to use things like div and span elements as the basic building blocks for other technologies that we want to build.
Chart it, point it, zoom it, press it.
So press it is the key phrase in there. Something else that we get for free when we use HTML provided by the browser is a lot of keyboard interaction. There are a number of HTML elements that are focusable and have interaction, keyboard interaction, supported by the browser by default. Links, buttons are the obvious two, also all the different kinds of form fields, but also slightly newer elements like details and summary that create disclosure widgets. And when we use any of these elements, the browser will take care of the keyboard focus for us and also the keyboard interaction. So we get that ability to have free accessibility. When we talk about focusable elements, something that's really important to remember is the order that someone who uses a keyboard to use the tab key to move between one focusable element and the next will get to things. We call it the DOM order. This is the order that the browser presents these elements in. And the DOM order is effectively what becomes the keyboard tab order. So if we take 3 buttons in a horizontal line on screen, number 1, number 2, and number 3, and that's the order that they appear in the code, that's also the order that someone who uses a keyboard will tab through them.
1 button, 2 button, 3 button.
So it's really simple. From a keyboard user's point of view, the order we put elements into the code is incredibly important. That governs the order they're going to get through things. So I mentioned interaction as well as being able to focus on these elements. The browser makes it possible to use them with a keyboard. So a link, for example, you can hit the enter key and it will work. A button, you can use the enter key or the space key and the button will do its thing. And with form fields as well, you can interact with them in different ways. Some can be activated using space or button. Others, you need the arrow keys to be able to select options from. Some, like checkboxes or radio buttons, can be selected using the space key. But again, the browser does all of this for us for free. So nice and easy accessibility is actually HTML as it was meant to be used.
Snap it, work it, quick erase it.
So what happens when all this kind of comes together in the browser? Let's take an example. I mentioned the details and summary elements earlier. They came along for the first time in HTML5, and they are a very quick and easy way to provide a disclosure widget, a button that you can interact with that will reveal more content on the page. Everywhere, it has to be said, unless it's Edge browser at the moment, which still doesn't support it, sadly, but they plan to, apparently. When we use these elements, the browser will build the document object model, the DOM, that's the code representation of the page that we can interact with using JavaScript and do interesting things to add functionality if we need to. But the browser will also create something called an accessibility tree. And this is a sister structure to the DOM tree, but it only contains accessibility information. It contains all the information that we looked at just a little bit earlier in this talk. The role of an element, any other characteristics about its state, or other properties that are important to accessibility. So if we were to look at the summary element and its accessibility tree representation in the browser, we'd find that that element has a role of button, because to all intents and purposes, that's what it is. And we also know that it can be focusable. And we also know that currently it's part of a bigger thing that can be expanded or collapsed. So there's a lot of information that's available in there. And we can see how a screen reader would interact with it.
Tequila button collapsed. Expanded. Makes me happy.
So a screen reader recognized that it was a button, and the user immediately gets a cue that they can interact with this. And the screen reader user is also told that something is collapsed, and when they hit the button, that has changed to expanded. And then it's very easy from there to move to the content and read the information that was revealed on screen visually. And again, that all comes just by using those 2 HTML elements with a little bit of extra content. All this happens through things known as platform accessibility APIs. These have existed since the mid-1990s, when Microsoft first introduced one into Windows in 1995. And they were a way for assistive technologies like screen readers, speech recognition tools, screen magnifiers, to ask for information about the things that appeared on screen. Before these came along, believe it or not, Assistive technologies used to guess a lot of the time. They would intercept the video signal on its way to the output device, and if that signal told them that there was a vaguely rectangular shaped thing on the screen, and there were 4 or 5 other similarly shaped objects on a horizontal line with it, and they appeared to have something that was a representation of text inside each one, it would take a reasonably educated guess that that was possibly a menu inside an application. And that was an extremely process-intensive way to go about doing things. Screen readers were quite slow. They often had to be highly customized to work with different applications and operating systems. And so these APIs gave them a different way to do things. Instead of doing all that guesswork, it enabled something like a screen reader to say to an object on screen, hey, who are you? What do you do? What are you there for? What's your role? What's your accessible name? What do I call you by? How do I refer to you? What state are you in? Are you open? Are you closed? Are you checked? Are you unchecked? It gave it a way to query all this information and get very decisive responses back, which the screen reader could then make available to people who are using that technology.
Write it, cut it, paste it, save it.
So an interesting question is saving it. What happens when we can't use all this lovely HTML and the APIs can't get at all that good information about role, name and state and all the other characteristics? And there is a solution in the form of accessible rich internet applications, or ARIA for short. It's a set of attributes that lets us polyfill or add in the missing semantic information. So for example, if we do have to use div and span elements as our building blocks, and lots of JavaScript frameworks do that, sometimes we want to create things that don't exist in HTML, like tab panels, for example. There are a whole bunch of reasons why we might need to add in the accessibility information for ourselves, and ARIA gives us an opportunity to do that. It has a role attribute, and that has more than 70 different values in the current ARIA 1.1 specification. And there are roles for pretty much everything you can think of in terms of an interface. For radio buttons, checkboxes, for tables, cells and rows, for tab panels, tabs and tab lists, for lists of all different kinds, for tree grids, progress bars, menus, menu bars, buttons, as I say, more than 70 of them. And if we need to indicate what the role of something is, where we're not using another HTML element, we can use the role attribute with the appropriate value. There are also 45 or more ARIA prefixed attributes, and these let us add in all that other information about the state of something. So ARIA pressed will indicate whether a button is pressed or not. ARIA checked will indicate whether a checkbox is checked or not. There are also ARIA prefixed attributes that will let us give names to things. ARIA label will let you define the name of something directly. ARIA labeled by will let you point to another piece of text somewhere else on the screen and have that used as the accessible name for a particular element. So ARIA is extremely versatile in letting us fill in missing accessibility information when it's not available. There are a couple of catches though. ARIA is only really useful to screen reader users. When it's used right, it can be highly useful to screen reader users, but it is just very specifically targeted at one particular audience. With the slight exception that Dragon, naturally speaking, a speech recognition tool, has a very, very small amount of support for a very, very small amount of ARIA. So that's the little bit of the exception, but the working rule is that it's a screen reader only technology for the most part. The other thing is that everybody thinks they've got this wonderful idea, wonderful way of solving all accessibility problems for screen reader users, and the truth of the matter is your best bet with ARIA is only use it when you absolutely have to, and even then, only use it sparingly, because it's very easy to add a little bit too much ARIA and cause complications for people when you really didn't mean to. So use it wisely, use it sparingly, but when you do, it's a very useful thing indeed.
Load it, check it, quick rewrite it.
So we'll pick up on rewrite it out of that. What happens if we were to try and do something like recreate the details and summary elements, but using divs and splans as our starting point? If you go to design-patterns.tink.uk, you will find access to a whole bunch of different design patterns, accessible design patterns, including the one that I'm going to be talking more about in the next few slides. So we'll start off with those div and span elements as our building blocks, and we will add in some content that starts to make them look a bit like a details and summary disclosure widget. If we add in a little bit of styling to make it look the part, we can present something that on first glance appears to be a functional component. If you're a keyboard user though, this is the experience you're going to get. You won't, because the div and span elements can't be focused on. The browser doesn't provide that functionality for us for free. You can't move to a div or span element using the tab key on a keyboard. So if you're a keyboard user of any sort, whether you use an assistive technology or not, that's you right out of luck. We can't use this component just yet. So we can start filling in some of that missing information. We can use the tab index attribute with a value of 0, and this will help us make that span element focusable. So that solves the first problem. It's added that element to the natural keyboard order of the page, so that's good news for keyboard users. It's now going to be possible to focus on that particular element. We can use the role attribute with a value of button, again on the span that's the building block for our button, and that will cause the span element to have a role of button in the browser's accessibility tree. So a screen reader coming along and asking for information about that element will now be told it's a button. So that's a little bit more useful information for screen reader users this time. We can use aria-expanded, an attribute that can be set to true or false. And again, we'll put that on the span that's pretending to be our button, and initially we'll set it to false, because when someone first focuses on this element, we want them to know that the widget is collapsed, that the information is currently not revealed on screen. We can then toggle it later when someone interacts with it to true, and a screen reader user will understand that the state of this component has changed from collapsed to expanded. As an optional attribute, we can add aria controls. This is a really useful attribute. We put it on the span that's pretending to be the button, and we point it to the div that contains the actual content to be revealed. And it creates a relationship that, sadly, only one screen reader understands. That screen reader is JAWS, and it means that if someone using that particular screen reader focuses on the button, interacts with the component to reveal the content, they've got a shortcut key that gets made available to them to help them move directly to the content that's just appeared visually on screen. Now, apart from the fact that it doesn't really have good support, sadly, the other reason that you really could choose whether to introduce this attribute or not at this particular point in time is because in this particular instance, when you interact with the button, logic and convention and habit, for us at least in the Western world, dictates that we'll move from the button on down through the content of the page, which means, in this case, a screen reader user would encounter the revealed content pretty readily. Aria controls really comes into its own where the thing doing the controlling, the button, influences or changes or updates content somewhere far away on the page, and it's helpful as a screen reader user who can't see that part of the page as it's changed to have a quick shortcut to jump focus straight to it. So it's optional in this case. We can use aria hidden to hide away a little visual icon that we got on the button. Visual accessibility is incredibly important. In this case, it's a little arrow icon that shows whether the widget is expanded or collapsed, again, mimicking the behavior of the details and summary elements when they're working together. But as screen reader users, we've got the aria expanded attribute to tell us whether the thing is expanded or collapsed. So we tend not to be so much interested in knowing that the icon is there as a visual cue. So we can use aria hidden, set to true, just to hide that icon away from screen reader users, but leaving it visually present so everybody else can make use of it. We can use the actual hidden attribute, an HTML attribute this time, to hide the content inside the div. Until someone interacts with this, we don't want them to see that content or to be able to access it in any way. There are lots of different ways you can hide content from various users, but the most robust way is to use the HTML hidden element attribute. It's the most robust way because it doesn't matter if someone is using their own style sheets. This content will still remain hidden from them, so there's no danger of someone using customized style sheets suddenly being able to see the content before they were intended to. It's right there in the HTML, so it doesn't rely on JavaScript or anything that might have network failout. So it's a really robust and resilient way of hiding content from all users in all situations. So we end up with some rendered code. If we put all this together, we end up with code that, when the JavaScript has pulled all those different attributes into place, has a lot of different attributes added. We've got a roll of button, a tab index 0, ARIA expanded, ARIA controls, ARIA hidden, and also the hidden attribute. So we've had to add in an awful lot of extra code, do an awful lot of extra work to get where we needed to do, but we're not done yet. We've got to add in the functionality because divs and spans don't do anything of their own accord. So we've got to make it usable with pointing devices, whether that's a mouse or a finger on a touch screen. We need to add some click functionality to get the thing to expand and collapse. We also need to make sure that the keyboard interaction is there. You remember earlier in the talk I mentioned that buttons can be activated with space or enter keys. So we need to listen out for both of those keystrokes. They have a key code attached to them, 13 and 32. And when either of those keys are detected, we make sure that the functionality of this disclosure widget kicks in and everything behaves as it should. The last piece of the puzzle is, of course, we need to actually provide the functionality. The browser isn't going to do this for us either in this case. So we've got to make sure that when someone interacts with the button, the content either is shown on screen or is hidden away again. We need to make sure that the ARIA expanded attribute has its state toggled between true and false so that screen reader users get access to that same information. And we wrap all this up together, and what we end up with is something like this.
Tequila button collapsed. Expanded. Makes me happy.
Which, if you remember back to the slide we saw with the screen reader example for the details and summary element, is nigh on exactly the same thing. And this is what I mean about thinking very carefully about when you use ARIA. It's a lot of extra work. I did a quick back of napkin test a few years ago. I tried to recreate a link just using a span element, and it added about 20% extra code. And that's one tiny little very simple element in the form of a link. Imagine if you do that now for your whole application interface, how much extra code it's going to take to make this thing accessible, how much more testing you've got to do, how many more moving parts there are, how much more complication you've just added, and places where things are likely to come unraveled. So if you can, really do think about using the right native HTML elements when you can, because the browser will give you all that accessibility for free, all your keyboard interaction and handling for free, and you're reducing the number of moving parts and things that you've got to test. So you're taking a lot of the headache out of the equation for yourselves as developers and creators, and there's a pretty good chance you're also going to make a much more robust and resilient experience for people who actually want to use your interfaces.
Plug it, play it, burn it, rip it, drag it, drop it, zip and zip it.
So zip, unzip it, drag and drop it. How can we test some of this stuff? Well, there are a lot of tools out there that you can use. Most browsers have good dev tools. Chrome, in particular, if you use that, has some excellent tools for checking the quality of your code, looking at the accessibility tree and discovering some of that information. And by all means, go take a look at your favorite dev tools and see what's out there that you can use. But the one thing I really recommend when you are actually building things and creating things is try it yourself. Getting a sense of the experience of someone who uses an assistive technology is an incredible experience. And you will have a screen reader on pretty much whichever platform or computer you choose to use, whether it's Windows, as long as it's 10, one of the versions of Windows 10. If you have any Mac, Apple products, iOS products, you have a screen reader built in. Linux has a free screen reader with it called Orca. Android has a screen reader called TalkBack. So it really doesn't matter which platform you choose to develop on or which you have in your pocket. Try turning on the screen reader and just giving the thing you're building a bit of a whirl. Don't make any big decisions on what you discover. I will stress this. Screen readers are kind of complicated things and they take a little while to get used to using, but keep trying it. Do it every time you build something. Every time you deploy a new feature, you put together a prototype or a proof of concept. Just get into the habit of quickly enabling the screen reader on your platform or your device and seeing if you can use it. Get a sense of what the audio experience of listening to content is like. Ask yourself, can I interact with the thing I'm building in all the ways that I need to? Can I get all the tasks done? You can do the same with Zoom. Again, most platforms give you some ability to do this. It's there in every browser, and so you can just go into your browser settings or use, on most platforms, Control++ or - to reduce the zoom. Whack it up to full zoom, make everything on screen as big as you can physically get it, and then have it wander around your website or the thing that you're building. Can you still make sense of it? Can you navigate around with it? White space becomes really interesting when you are using things in massive zoom. I've actually seen people get slightly seasick, motion sick, because their beautifully white space designs suddenly became vast expanses of whiteness in the middle of a page with no landmarks or places to orientate by if you use zoom. And that's really quite a disorientating and unsettling feeling. So again, just experiment, get used to getting a sense of the experience of someone who has partial sight or for whatever other reason needs to zoom your content in a little bit or all the way up. Lastly, try unplugging your mouse or your trackpad and having a go with the keyboard. Can you get to all the interactive components that you need to in the interface? Can you interact with them? Can you make them work? Can you complete all the tasks that someone is likely to expect to complete using just the keyboard? And if you can do all of these three things, you'll start to get a really good idea of the experiences of other people. Putting yourselves in other people's shoes is a really valuable experience. And the more you do it, the more you'll get an understanding of what those experiences are like, what the challenges are like, and the better a feel you'll get for when you're building stuff as to the choices that you can make.
Lock it, fill it, curl it, find it, view it, code it, jump and lock it.
Okay, so we're going to take a little bit of a different trip now. Who remembers the film from the mid-90s called Space Jam? Who's willing to bet that the website is still up there? Well, it is, and it's a lovely website. It's got this great, circular design of stars and a kind of star field, and all the information about the film. And it is still out there. It's 22 years old now. And I believe actually that Warner Brothers tried to take it down a couple of years ago, and the interwebs just howled loudly, and they put it back because it's kind of just an archaeological treasure in web terms. So why am I talking about this? Well, if you go and have a look at the HTML of that website, you'll find some really interesting things. Now, anybody who's my age and was around coding stuff back in the mid-90s will find this horribly, horribly familiar. But we had things like all the colors for links and text was hard-coded into the HTML. The background colors, the background images that in this case form those star fields that were part of the design, they're all put there inside the HTML. They're hard-coded. This is in the days, of course, before CSS came along. Layout was all done by tables. We put everything into rows and columns, and we gave them fixed width, and we didn't so much as let them move or breathe or wiggle even a little bit, because this was the only way that we could do even remotely complex layouts. Formatting, we use things like a center element in HTML, a non-breaking line element in HTML. Everything was right there in the HTML. It was hard-coded, tied down, nailed to the floor, and utterly unchangeable by anybody or anything. Even fonts were hard-coded into the HTML. The size, the color, the font face, all of it was right there. And this, I suppose, perhaps, is one of the reasons that the site is still there and is still actually largely usable, accessible, and functional, even on today's web. It's fixed there in time. But the price of that is that we have no ability to change any of it. It was designed for the average screen size at the time, something like 600 by 400 pixels. We obviously have many more screen sizes at our disposal now, ranging from enormous, great big TVs to tiny little watches. And this website doesn't cater to any of them. It is the size it was designed to be, and that's it. We can't change the colors, we can't change the font size, we can't change the font face. So if you need to change any of those things because you're out in bright sunshine and you can't see them properly, or because you're partially sighted, whatever it may be, you're bang out of luck with this particular website.
Surf it, scroll it, pose it, click it, cross it, crack it, switch, update it.
So we're back to this idea of upgrading it again. This time, what the web did to upgrade. Just a few months, actually, after the Space Jam website was launched, CSS1 came along. And with it, we started to get the first ability to use style sheets to apply things like font faces and colors and many of the other style characteristics of content. As an interesting aside, CSS is one of two things in my life I have ever predicted would not be a success. The other one was Google. So frankly, don't listen to me if I ever give you a prediction about technology in the future. But CSS did, of course, take off, and it was followed not long after, in '98, with CSS2, and this introduced some more features that gave us different ways to add content into pages and change and characterize the styles of our designs. I'm going to focus on something from CSS2, which were the before and after selectors. This enabled us for the first time to use CSS to add actual content to the page. So not just to change the way something looked, but to actually change what something was. And so if we take a quick example of a link on the page, we could use CSS to add some extra text inside the link, more text than is currently included in the HTML. Here's what the CSS2 spec says about doing that. It says that when you add content, generated content, it shouldn't affect the document tree. It shouldn't affect the document model of the page. And if you remember a little earlier, I mentioned that when the browser gets an HTML element, it creates the DOM, and then from there it creates the accessibility tree. So before and after content doesn't get as far as the DOM in the browser. So things are not looking good from an accessibility point of view if it's really likely that that information isn't going to make it into the accessibility tree, where assistive technologies can get their hands on it and make that information available to users. So if we take our example link, this is what it looks like in the HTML and the DOM. We have a simple anchor element, and it just has the one word tequila in it. As far as the HTML and the DOM is concerned, there is no sign of the extra content that we've added in using the CSS after element. Good news is, this is what screen readers say.
Name it, read it, tune it, print it, scan it, send it, fax, rename it.
Oh, you know, actually, if my screen reader sounded like that, life would be a lot more interesting. But the question is, rename it. So what does happen? Here's what a screen reader will say when it gets access to that link with the one word tequila in it, but some extra information added using the after selector.
Tequila makes me happy. Link.
Yay. We get the extra information. Quite unsurprisingly, against all the odds, against what the spec says, against what we've come to learn about the way such things work. And the reason is that pretty much every single browser out there, apart from Internet Explorer, cheats outrageously when it comes to the before and after elements. It doesn't add that content to the DOM, so it does what the CSS2 spec says it should. But then it sneaks that information straight into the accessibility tree. Each browser does it in a slightly different way, but the upshot is that the CSS added content is added into the accessibility tree, so that when something like a screen reader goes to the browser and says, tell me all about this link, it actually gets both pieces of information. So that's a hurrah for accessibility, a bit of unexpected good accessibility where we might ordinarily not have thought it was going to be possible. Oh. Something else came along more recently in CSS in the shape of Flexbox. And other modules that have come out since, Grid being a notable one. And what these new CSS3 modules enable us to do is rearrange content visually on screen. So we're back to just thinking about how stuff is visually presented on screen. And there is a potential for that to cause some problems from an accessibility point of view. If we take our button elements example from earlier in the talk, our 3 buttons, number 1, number 2, and number 3 across the screen, you'll remember that this is how someone who uses a keyboard with a screen reader will access them.
1 button, 2 button, 3 button.
Lovely. All the buttons in the order we put them in the HTML. Very nice, very simple. Everything matches up, and everybody's happy. But if we use the display property in CSS with the value of flex, to turn this into a flexbox area, and then we use the CSS order property to change the visual appearance of these 3 buttons so they appear in reverse order on screen, number 3, number 2, and number 1, some interesting things start to happen from the point of view of keyboard and screen reader users.
1 button, 2 button, 3 button.
So if you're listening to that and you're a screen reader user, you're thinking, well, that's okay. We've still got buttons 1, 2, and 3 in the right order. The problem is that if you're a keyboard user and you're looking at what's on screen, you also hit those buttons in that order, 1, 2, 3. But because the buttons are rearranged in the opposite order on screen, there was a complete mismatch. You started moving from right to left through the buttons instead of the expected left to right that's common in Western culture. So we end up with a disconnect between how things are visually on screen and the order we expect to navigate through them, and the actual order that we navigate through them. So what can we do? Well, the CSS spec, somewhat unhelpfully in this case, says if you're going to use Flexbox or one of these other modules in CSS for rearranging the visual appearance of things, don't do it when you're rearranging things that need to be interacted with. Now, on one hand, that sounds like great advice. It's very practical and it solves the problem. But these CSS modules make things so much easier for developers. They solve problems that we've had in visual graphic design for many, many years on the web. So asking people to take something that solves a whole bunch of technical problems they've had for years and years and years, and then not use it to solve those problems, is a pretty unlikely scenario, truth be told. Yeah, you can't give someone candy and then really take it away and expect to have a good outcome for anybody. So are there other things we can do to solve this problem? We looked at the tab index attribute earlier to make a button of our fake details and summary element focusable with the keyboard. So could we use tab index with actual numbered values to rearrange the tab order through the content so it matches the visual presentation on screen? So could we apply tab index 3, 2, and 1 so it all fits together? Well, this is what happens when you try with a screen reader.
3 button, 2 button, 1 button.
So the short answer is yes, we could. But when was the last time you came across a website that was just 3 buttons in the middle of a screen? The truth of the matter is that websites are complex things with lots of focusable bits and pieces included in them. And once you start applying a tab index with an actual number value, as we just did then to solve that problem, you start changing the natural tab order of everything in the interface. Because if you put tab index equals 1 on an element, it becomes the first focusable element on that page. Doesn't matter how much stuff there is on the page before it. First time you hit the tab key, that's the element you're going to get focus on. So if you take control using tab index with actual number values, you've got to keep control. In other words, you've got to take responsibility for the tab order of every single thing on screen to make sure that it follows a logical path for anyone using a keyboard and looking at the content. And quite frankly, that's a lousy idea. It really hurts from a development point of view. It's far much more brain effort than I'm ever prepared to put into something. It's actually not good if you work in a team, because you might figure out the tab order for all your content, and then you might leave, and somebody might come along after you, and somebody will say to them, can you just add in a new focusable feature on this page? And unless your documentation is really superb, and let's face it, never is, some poor soul is going to come along and utterly break the tab order. Taking control of the tab order is a bad thing from a user point of view, from a user experience point of view too. It tends to confuse things, it breaks expectations. So tab index, yes, you could solve this problem if you were looking at it in a very microscopic and isolated example like my 3 buttons, but it's really not advisable when you're talking about an entire web interface. Could ARIA help us out? There is an attribute called aria-flow-to. And it enables you to create a way of navigating through elements on screen. Now, you'll remember, of course, that ARIA is just for screen reader users. But we could use aria-flow-to say, when you're focused on button 3, enable navigation to button 2, and from there to button 1. So, perhaps there's hope yet. This is what happens for a screen reader user, though.
Tab 1 has flows to button. Tab 2 has flows to, has flows from button. Tab 3 has flows from button.
Anybody else confused? Yeah, me too. So the problem is that, firstly, the tab key still got things wrong. The visual order is still 3, 2, 1, but from a screen reader point of view, we still got 1, 2, 3, which, if we can't see the buttons, maybe that's not so much of a problem. But of course, there are plenty of people out there using screen readers who can see some too. And then we got this extra information, has flows from, has flows to. I can never remember what the keyboard shortcut in that screen reader is for using that navigation anyway. From a development point of view, we haven't actually solved the problem, we've just added a new one, because we've now got the Flexbox keyboard disconnect problem, and we've also got to try and think about a way to control the tab order for keyboard users, which means we could possibly use tab index. And then we'd have to use ARIA Flow 2 to think about it from a screen reader user's point of view. So we've just made things really messy, really complicated, big headache for developers and creators, and we really haven't solved anything for users. So yeah, adding another navigation method is a really bad idea when you're trying to solve a broken navigation in the first place. There is something interesting though. Firefox had a bug, and this was the result of the bug. If we just go back to using the Flexbox example of our 3 buttons, so they're displayed 3, 2, 1 on screen, this is what Firefox did with it.
3 button, 2 button, 1 button.
It did a bit of an after selector number on us. It actually solved the problem. So from a development point of view, you didn't have to do anything other than use the CSS as you intended to. From a user point of view, Firefox self-corrected. It made the tab order for keyboard users match the visual presentation of the code. They called it a bug because it's not what the spec told them to do. We tried to get the spec changed and we couldn't, and sadly, I believe Firefox has now fixed this bug. So the one useful solution that could have actually become a really viable production level solution that would have made things easier for all concerned, for the time being at least, has disappeared a little bit off our radars. But maybe there is hope in the future, who knows?
Touch it, bring it, pay it, watch it, turn it, leave it, stop, format it.
So here we are, almost at the end. And format it is the phrase I want to pick up on. This is, I think, how people often feel about accessibility. There's a lot to take in, a lot to think about, a lot of different humans out of there who want to do things in different ways, need to do things in different ways with different technologies, and sometimes accessibility can feel pretty scary, pretty big, pretty overwhelming. You can look at the thing you're building or the thing you've built or you're responsible for, and you can realize that you've got a whole bunch of stuff that you need to look at from an accessibility point of view, and you might not know where to start. You might think, I can't do this, and there's so much important stuff here that needs to be done, and it impacts so many people's lives and abilities to do even simple tasks on my website or my app. Oh my goodness. So there's a couple of things I want you to think about. Accessibility is a remarkable thing. If you change one thing, you'll make a difference to somebody somewhere. Actually, you'll make quite a bit of a difference to quite a lot of somebodies somewhere. If you make something keyboard accessible, if you test it with a keyboard like I was suggesting before, and you fix a few things to make a few more things keyboard accessible, there's a huge amount of people out there who are going to benefit from that. If you add alt texts to your images, again, there's an enormous number of people out there who will benefit from that one thing. So a really important message, and something I hold really close to my heart, is this. Accessibility doesn't have to be perfect. It just has to be a little bit better than yesterday. And if we can all go out there and try and make that happen, one little change at a time, one little improvement at a time, bit by bit, step by step, we'll start making things better for an awful lot of people. And we can really do it when we approach it in those terms. So, Technologic, here it is. If you're ever thinking about accessibility, all in one go, this is the tune I want in the back of your minds for the next days, weeks, months, years that you are out there building stuff on the web. Are you ready?
Buy it, use it, break it, fix it, trash it, change it, mail, upgrade it, charge it, point it, zoom it, press it, snap it, work it, quick erase it, write it, cut it, paste it, save it, load it, check it, quick rewrite it, plug it, play it, burn it, rip it, drag it, drop it, zip unzip it, lock it, fill it, call it, find it, view it, code it, jump and lock it, surf it, scroll it, pose it, click it, cross it, crack it, switch, update it, name it, read it, tune it, print it, scan it, send it, fax, rename it, touch it, bring it, pay it, watch it, turn it, leave it, stop, format it. Technologic. Technologic.
Because remember, whatever else happens, we're human after all. Thank you very much.
I've brought you water
Thank you.
because I thought you might want one.
Okay. Oops, sorry.
Come on this way. And we have very little time, so
Sorry.
it'll be two
Yes.
questions.
Okay, no worries. Just
So it'll be
whatever you
what do
need.
you do with the W3C? And then I'll go into the AOM and the DOM.
Okay, sounds cool.
All right.
Yeah.
This is the part where we get to improvise. Briefly. Hello, everyone. My name's Greg Hannick. I'm in Indiana University's User Experience Office Accessibility Architect. And I am quite pleased that we had someone so wonderful, so important to our entire digital experience able to be here with us. In just a few sentences, could you explain what it is? Because so many people here won't know what you actually do with the W3C and how important that is. A couple of sentences. What do you do there?
Lots of things. So I'm on the advisory board, which is the small group of people that advises Tim Berners-Lee and the W3C management team on governance and strategy. But I'm also co-chair of a working group called the Web Platform Working Group, which looks after what I call the odd sock drawer of specifications. We look after HTML, which is probably the most well-known, but also a whole bunch of different things like screen orientation API, push notifications, gamepad, and many more besides, which is why I call it the odd sock drawer.
Wonderful. So you're basically in charge of a group that's responsible for how we experience the World Wide Web.
Yep, a lot of it. Yep.
Yeah, not a big thing. Now, your talk just covered important things like the accessibility APIs that are built into the operating systems and the DOM and how that information works together to bring information to assistive technology right now. But there's a group that's proposing something new. Is that correct? And what implications would that have for us in the future?
So some of the browser companies are working on something called the accessibility object model. And for the first time, it will let developers access the accessibility tree in the browser directly. So at the moment, if you're in assistive technology, you can get to it. But as a developer, you can't. You've got to do all the accessibility in HTML by adding attributes and ARIA and let the browser take care of the rest. So this will be a JavaScript API that will let developers add things to the accessibility tree and remove things and get information directly, which on one hand is very, very exciting. It has lots of possibilities. But there is one really scary thing. What it will be possible for developers to do is detect when an assistive technology is running. They'll be able to tell when someone executes a command with a screen reader or a speech recognition tool. And on one hand, again, that sounds fantastic. You know, we'll be able to build web technologies and websites that are very responsive to assistive technology users' needs. But the bit that concerns me is the privacy angle, because for the first time, it'll be possible for a website to know that I have a disability because I'm using an assistive technology. And the privacy implications of that are, to my way of thinking at least, pretty scary. We've got some serious thinking to do, I think, to make sure we don't go down the wrong pathway with something like that.
Thank you very much. We may have an opportunity to talk more about that in the panel later this afternoon.
Okay.
So in the interest of keeping on our schedule, we're going to keep moving on.
Cool. Great, thank you.
Thank you,
very
folks.
much.